Alright, my dear students, you're welcome to Professional Academy online classes. Right, I'll be taking you through some series of topics under the physics, right? But for today, I'll be explaining under the force and motion, and I want you to listen carefully. And also, you're free to send your questions. I'll be giving you the email through which you can send your questions as we go on. Alright, we're going to be looking at the topic force and motion, and I would like to start with topic motion. Alright. Number one, we want to know what the definition of motion is. Alright, we should know that motion is the change in the position of an object or the displacement of an object in a given time. Alright, if we know that, we understand there are different types of motion. As we've been taught, we know there is something called random motion, right? We know that this random motion is also called Brownian motion. Alright. There is also something called translational motion. Translational motion is also called linear motion. Alright, there's something called oscillatory motion. Alright, and there's something also called rotational motion. Not only that, there is something called relative motion. And you can also have something that is called periodic motion. I'll explain. Alright, when we say a motion is a random motion, or we say it's a Brownian motion, we mean a zigzag motion of an object or a haphazard motion of an object without a specific pattern or direction. What I mean is motion without a specific pattern or direction is a random motion. And we can give the example of this to include particles in the air. Particles in the air. Alright, not only that, footballers on the football pitch. Alright, if we look at another one which we call translational or linear motion. Alright, translational or linear motion, from the word linear, we mean motion of an object on a straight line. Motion of an object on a straight line is a translational motion. Not only that, we have oscillatory motion. Oscillatory, to and fro motion of an object. When an object moves towards a particular point and is coming from that reference point, that is an oscillatory motion. We have the example of this in pendulum bob. The motion of the pendulum bob is also an oscillatory motion. Alright, we look at rotational motion. Rotational, if we imagine the motion of the blades of a fan, we understand it's a kind of rotational motion when the object traces out the center of a circular path. Such is rotational motion. So we can give an example of that as the blades of a fan. Blades of a fan. Alright, we also have what is called relative motion. Of course, when you say relative motion, you're kind of comparing the motion of a body with respect to reference body. What does that mean? If I am here and I compare how far I have gone from where I am coming from, it's a kind of relative motion, it's a kind of difference of motion, is when you kind of compare how far you have gone from a reference point. Oh, Ibadan is far from Lagos, and maybe you are in Ibadan and your reference point is now from Lagos. Such a motion of the object is a relative motion. And there is another one we can also look at. It is a periodic motion. Period, which is indicating time. It's telling us that this is a time-dependent kind of motion. Alright, even if we look at the motion of the hands of the clock, we understand. And take for instance, we have a motion of the hand of the clock to read something as this. Alright, you will agree with me also that the motion of this hand of the clock could read twice a day. Or what does that mean? We can twice in 24 hours. We can have this to give us 6 p.m. in the evening time. After an interval of 12 hours, we understand the motion of the hand of clock will read exactly like this, and it could mean 6 a.m. in the morning. Such a motion of an object that is time dependent is also called periodic motion. I hope you understand how I have carefully explained all of these various types of motion we have. But not limited to this, I'll be taking you through some points also under parameters of motion. Parameters of motion, look up here. Under the parameters of motion, there are some things we must understand. all right, which will include but not limited to distance. We must understand what is distance. We also have displacement. We must understand what is displacement. Not only that, we can have velocity. We must understand what is velocity. We can also have the average speed, not limited to that alone. We can also have the acceleration. Acceleration, we must understand. Not only that, we can have uniform motion. All right, we must understand what is uniform motion. Not only that, we can also have uniform accelerated motion. Uniform accelerated motion. Not only that, we can also have time, right? We're going to be looking at all of this as we come to learn motion. There are some things we must understand. All of these the parameters of motion that I've listed, they are essential for correct understanding of motion as we're building the foundation. Number one, I'll look at distance. Well, and before now in your primary school, your teacher would have explained what distance is. Of course, distance is the length between 2 points. When you kind of fix a point and another point, the length between them, the gap between them, the space between them in form of length could mean distance. Distance between 2 points is, the length between 2 points is our distance. And so you understand in primary school, our distance, which our teacher has represented with S, is always the product of our average speed times time. Of course, so I can write it shortly and say that my distance now, which is S, is my average speed multiplied by time. Of course, now to cut something, to bring in something, you understand distance is a scalar quantity. What does that mean? It has magnitude but no direction. Understand to average speed here is also a scalar quantity. What does that mean? It is a physical quantity that has magnitude but no direction. Time also is a scalar quantity. Distance is scalar quantity, average speed is scalar quantity, and time is scalar quantity. I come to explain displacement. What does that mean? Actually, many times, but I need to tell you that the unit for distance is meter. Maybe I need to stress that. The unit of distance is meter. That is the system international unit. The unit for the average speed is meter per seconds, meter over seconds, meter per seconds. And of course, the unit for time is seconds. Let me bring you back to displacement. Many times the students don't understand. They kind of confuse distance with displacement. And many times our teachers, they're not careful in the use of the word. Number one, we must understand displacement is a vector quantity. What does that mean? It is the length between 2 points in a given direction. When you kind of specify the direction of motion, it becomes a displacement. What does that mean? If I say from here to Lagos is 20 kilometers, that's good. That is the distance. But if I say I moved from here to Lagos 20 kilometers in the direction of north 30 degrees east, of course you'll agree with me, this is the magnitude and this is the direction. The both combined together makes it a displacement. So I can say displacement is the direction or is the length between 2 points in a given direction. How do we calculate displacement? Displacement is given as the product of the velocity. Displacement is the product of the velocity and time. Velocity times time is my displacement. Of course, unit of displacement in meter, unit of velocity in meter per seconds, and unit for time in seconds. Alright, I'll quickly move down to talk about velocity. Of course, you're a mathematician. If we say displacement is equals to velocity times time, what does that mean? That means that we can make velocity the subject of formula here, and so we can have displacement over time. Exactly, you got it. So if I have displacement over time, what does that mean? I can write it in words and say velocity is the rate of change of displacement, or the ratio of displacement to time is my velocity. Exactly. Just as we did to distance, just as the way we did to displacement, we can do the same thing to distance. If I make average speed the subject of formula, I can write that the average speed also, the average speed will be my distance. The average speed will be my distance all over time. Exactly. So we have this all over time. Alright, so that is that. Under the acceleration is the rate of change of velocity. What does that mean? What we mean is that when an object changes its velocity with time, so we say such a body accelerates. What does that mean? Look up here now. I have acceleration. Acceleration now will be equals to change in velocity. Change in velocity all over time. So having this statement all over time, then I can short my acceleration. Acceleration is equals to change. Let this delta be my change in velocity all over time. Alright, when we say there is a change of velocity, or maybe we say there is a change in price of a commodity market, what does that mean? There is an old initial price and now there is a new price. So we can say there is a change of price of a commodity. So when we say change in velocity, when I say change in velocity, what I mean is that there is a new price and there is an old price. The V here is indicating final or new velocity, whereas the U you see there is indicating the initial old velocity. Alright, so when we have change in velocity, we're saying final minus the initial. So the acceleration there will give us V minus U all over T. Alright, and I'm sure you know some little mathematics there that if you cross multiply, like your primary school mathematics, you're going to have something that will look like this. If you cross multiply, you're going to be having AT is equals to V minus U. Not only that, you can bring your minus U here to have AT plus U is equals to V. Or better still, I can write it and say V is equals to U plus AT. Do you understand this, dear students? Alright, so when we understand that, it is good. Then we can have what is called uniform motion. Alright, as we look at this, we understand that in the study of our motion, we must understand what does it mean when we say uniform motion, uniform motion. Actually, we must understand that when we say uniform motion, we mean motion of an object with a constant speed. As we come to solve some problem, we could be having some questions to tell us an object is moving uniformly. What does that mean? We must understand that is the motion of an object with a constant speed. Let us sketch the graph of a uniform motion. Look up here for a moment. Uniform motion. Alright, if we look at uniform motion, I told you that it means motion, because if you look at the word uniform, uniform means constant, not changing, the same thing, the same motion, constant motion, not changing motion. We're simply talking about the speed, because if the speed is zero, the object will not move. So we understand uniform motion here is talking about a constant speed motion, constant speed motion, constant speed motion. And how can we have a motion of an object to move with a constant speed? Let us consider, let us sketch the velocity time graph. For this, sketch velocity time graph of a uniform motion. Alright, in that case now we're going to be having velocity on the vertical axis on this time, and we're going to be having velocity on the vertical axis and our time on the horizontal axis. Velocity, which is in meter per seconds, and our time on the horizontal axis in seconds. Alright, velocity on the vertical and time at the horizontal. Velocity time graph. Being a constant speed motion, it is always parallel to the horizontal axis like this. Such a motion that starts from the origin, possibly this kind of motion is a constant speed motion. Constant speed. The speed does not change even as the time changes. And what does that mean? It has zero acceleration. It has zero acceleration. Zero acceleration, meaning there is no acceleration for an object moving uniformly or with a uniform speed. It has zero acceleration. I move down to uniform acceleration motion. Uniform acceleration. Of course, when we look at uniform acceleration, we can be tempted to say constant acceleration. The same thing, because I told you that uniform could mean constant. So when we now have a constant acceleration, we're going to be having something like this. Let me quickly show you. So if we're going to be having that, we're going to be having something like this. Let me quickly show you. For a uniform acceleration, that means a constant acceleration, right? So if it is constant acceleration motion, we're going to be having our velocity on the vertical axis. Having our velocity on the vertical axis in meter per seconds, we have our time on the horizontal axis in seconds. Alright, being a constant acceleration motion, it must pass our graph, our line of best speed must pass through the origin. And so we're going to be having something like this as our constant acceleration motion graph. This is a sketch on a velocity time graph, right? When we sketch a constant acceleration graph on the velocity time graph, velocity on the vertical axis and time on the horizontal axis, the graph must start from the origin, all right, and it must maintain a straight line like this, telling us that if we pick a value of velocity here and we trace it to the line of best speed, we trace it to the horizontal, or we pick a line of best speed from we pick a point from the vertical axis velocity, we trace it to the line of best speed and we trace it down, we're going to have the same acceleration at any point on the graph. No wonder it is a constant acceleration graph. So you understand what we mean now when we say uniform acceleration. It means constant acceleration. What does that mean? Acceleration that does not change throughout the motion. Alright, lastly we look at time, because we understand in our study now time is expedient. Alright, so we say time is the duration for which a motion or an event takes place. You understand? It is also a scalar quantity. Maybe I need to tell you that time is a scalar quantity. It does not tell any direction. It gives the magnitude always. So it is a scalar quantity and it tells the duration for which an event takes place. And you must understand acceleration here is a vector quantity. I've taken time to explain to you. Speed is a scalar quantity, whereas velocity here is a vector quantity. It has magnitude and direction. So under this force and motion today, I have been able to explain to you, number one, the definition of motion. I've been able to tell you that motion is the change in the position of an object with time, or displacement with time of an object. I've taken you through the series of the types of motion we have, and I brought you to explain to you parameters of motion. In our next class now, I'll be taking you through Galileo Galilei statement under motion, and I'll be taking you through Isaac Newton's law of motion, and we're going to be writing the equations of motion, and we'll see how far we can go. Before I see you next time, I want you to aim high, dream big, and never give up. I'll see you in my next class. Thank you for coming.